Hello, welcome to today's class. In today's lab class, we will look at the half subtractor. We have already seen the truth table for the half subtractor, and here is how the truth table looks like. And the logic circuit to implement this truth table would be something like this, which I have already implemented. So here is the logic circuit that would implement the truth table that I have shown just now. And in this logic circuit, as you can see, I have two inputs x, y, and two outputs borrow and difference. Let us verify that this logic circuit in fact implements the truth table that I have shown here. And for that, let me just write down the input names x, y, and b and d, and let me just try out the different values. So if we go to the logic circuit, and if I put 0 0 as the input, I get 0 0 as the output. So let me write it down. 0 0, when the input is 0 0, the output is 0 0, and when the input is 0 1, I change the input to 1, then the output is 1 1. I get the output 1 1, and when I give the input 1 0, the logic circuit that we have constructed gives us the output 0 1. So B is 0, D is 1, and finally when I give the input 1 1, and so when I have the input 1 1, then the output is 0 0 0 0. And as you can see, the two tables are matching, so we can say that this logic circuit indeed implements the truth table of the half subtractor. How actually we come up with this logic circuit, we will study that as we make progress in our theory class. There we will, and once we study those concepts, you will know that how to build a logic circuit for any given truth table. But before I end today's class, I would like to mention one more thing, that we can build this half subtractor in a different way. Let me show you the other logic circuit for the half subtractor. And here is another logic circuit which implements the truth table for the half subtractor. So this is also a half subtractor. Again, we have two inputs x and y and two outputs b and d, and then using a NOT gate I compute x prime, and using another NOT gate I compute the y prime, and this is how I connect the inputs. We have two AND gates and one OR gates, and let's see the output for this logic circuit. As you can see, for 0 0, I'm getting the output 0 0, which is matching with this truth table. If I change the input to 0 1, I get the output 1 1, which again is matching the truth table here. And then if I change the input to 1 0, I get 0 1. So for 1 0 I get the output 0 1, and finally for 1 1 I get the output 0 0. So for 1 1 I get the output 0 0. So again, this is another logic circuit for the half subtractor. That's all for today's class. I'd like to stop here. In the next class we will look at the logic circuit for the full subtractor. Thank you. Bye.